Welcome back to deploying models. So in this section, we'll talk about the last part, which is the TensorFlow serving. So far, we've been talking about REST-based web services as implemented by this sort of infrastructure, where a request coming in from your browser will go to a web server, and the web server will then go through a WSGI or WSGI gateway to talk to a Flask server, and then the Flask server will actually talk to the AI inference engine, which will actually use the safe model, your safe train model, to actually make a prediction. Now, this is one way to actually implement the REST-based web services to access the trained model with an AI inference engine. Now, what if you could actually wrap this whole thing up with a dedicated integrated server that contains all these different services within one server itself. So this is actually what is being provided in the TensorFlow serving. So in the TensorFlow serving, it will not have all these separate pieces as separate servers and pieces of infrastructure. It will be an integrated um, environment. So serving your model with the TensorFlow serving. Now this is not from NVIDIA, but it's actually from TensorFlow itself, which is part of Google. So TensorFlow serving, URL is here, is actually a flexible, high performance serving system for machine learning models designed for a production environment. So it's really meant to handle a large number of requests coming in as from mobile or from a web applications. It also uses web style API, what we call the REST web services as well. It's just that the mechanism they use to be able to handle those web requests and retrieve the information using the REST API is different from what we described in the previous set of slides, right, or in the previous video. So TensorFlow serving is a more integrated way of doing it. So it's only one server that actually integrates all those different things that we talked about, being able to handle the web request, being able to convert it into a request to AI inference engine, and executing the AI inference engine to actually retrieve the safe model, trained model, and actually generating the response from that. So it's an integrated way of doing it. So TensorFlow serving makes it easy to deploy new algorithms and experiments while keeping the same server architecture and APIs. TensorFlow serving basically provides out-of-the-box integration with TensorFlow models. So if you're using the TensorFlow framework to train your model and to save your model as a TensorFlow safe model, then the TensorFlow serving is the most straightforward approach to actually deploy in the production environment, because everything would be working out of the box without you having to integrate any other components together. But if you are not using TensorFlow, then this solution will not work as well. So maybe the previous one, where you use your own NGINX server and then integrate the Unicorn to it, would be more flexible. But if you're within the TensorFlow environment, this would work fine. So the architecture is very much similar to the previous one, except that in this case, it's not multiple servers, but just different components running within one server. So you can see that the model loader will load it from the model repository or model source. This is basically the storage for all your trained models. You have a model manager which will take into account different versions of your trained models. So it will manage multiple versions for you. And then the loader will load in the model and then get it ready to be executed within the inference engine. And remember, the web server as well as the Unicorn, WSGI plus the Flask, all this is actually integrated into one single component called the servable handler. So the servable handler receives the request from your client and then passes it to the model. And the inference will be running the inference engine will run the model and then retrieve the request and then send it back to the client. So the model source provides plugins and functionality to help you load models or in the TF serving terms or TensorFlow serving terms, it's servables from various locations, right? So the servables may be contained within the Google Cloud, or it may even be located in another cloud service such as Amazon S3 bucket. And once the model is loaded, the next component, the model loader, will be notified. The model loader provides functionality to load the models from the given source, independent of the model type, the data type, or even the use case. In short, the model loader provides the efficient functions to load and unload the model or servable from the source. So basically, the model loader is like it gets the model ready for the inference engine from the original source. In the TensorFlow serving architecture, the model manager manages the life cycle of the model. So different versions of the model, when it needs to be loaded, which version should you load at which time. This is all managed by the model manager, because the model may have been trained with different subsets of data, and you need to actually load in the correct version to make the correct prediction for a particular application. Right, so if you, that's a funny example would be if my model has been trained with durians, and I want to make an inference on oranges, I obviously need to actually use the model loader to load the model that's been trained using oranges, because I can't make any predictions about oranges using a model trained on durians. Right, so this is basically the idea for the model manager, just to take care of different models that have been maybe trained with different data or different versions of the data, and even with different algorithms or different sets of hyperparameters. Now the servable handler, the front end, basically handles the gateway functions, right? Whatever request is coming in from the client, it's going to convert that, handle the API call, and you can see that in the servable handler, they actually provide two types of API. One is the very Google specific mechanism called the Google gRPC. Actually, this is a very common API used for many Google services, but the more generic one would be the REST-based API that we mentioned before. So this servable handler is able to take care of both of these request types. So the one that we are already familiar is the REST-based. So now basically the servable handler takes over the function of the NGINX, as well as the Gunicorn and the Flask server. So all those things that were used to handle the requests, they are being handled by the servable handler, and it is a high performance handler. Is able to do the multi-threading, parallel execution that is actually implemented in the Gunicorn and the other infrastructure to make it able to handle many requests per second. So all this work very well if your model source, etc., is actually designed and trained using the TensorFlow framework, because it will assume that the format of the models, etc., is already in a form that it can load in easily and actually get running very quickly. The servable, it will take over, of course, many of the functions of the web server previously, and on top of that, it also adds in this additional ability to handle gRPC, the very Google specific API calls. This is commonly used for many Google services like Maps, etc. And with that, I thank you for your attention, and we'll continue this story in the next set of slides.